Hello everyone, I'm Tamás Lovas from BME, and this is the last video of the Capturing Reality module, which is about the conclusions, which is we are drawing conclusions considering all the previous videos in the Capturing Reality module. So we ran through the comparison of positioning technologies, the comparison of data as end product. We will compare the laser scanning with photogrammetry and laser scanning with traditional lens surveying, and I have a separate slide from crowdsourcing as an interesting data acquisition technology. So if you want to compare the positioning in the technology, as you can see on the left side, it can be satellite imaging, aerial mapping, UAV photogrammetry surveying, terrestrial laser scanning, mobile mapping, as what we discussed in the previous videos. The reference information comes from ground control points or using digital elevation models or direct orientation, and you can see the difference between them. So we can use ground control points, but we can use DEO in case of aerial mapping. Usually in case of surveying, you are using reference points, we are using GCP and terrestrial laser scans, and so on. So if you want to compare the data, the end product, what kind of data, the dimensionality is coming out, then you can see that certain technologies are providing both 2D or 3D data. Obviously, we can derive 2D data always from 3D, but in many cases, only 2D is available. If you want to compare laser scanning with photogrammetry, the major difference is we have an irregular point cloud, like it's only regular in a surface of a sphere, and compared in case of photogrammetry, a grid like pixels in a picture. There is spacing in case of point cloud, distance between the points, the gaps, and pixel size in case of a picture, an image. We have polar geometry in case of laser scanning, as we are measuring horizontal and vertical angles and one distance. And we have perspective geometry in case of image. We have active technology in case of laser scanning. We are emitting a laser beam and measuring the time or phase difference on the returning signal. And we have passive technology in case of photogrammetry. We are capturing the reflected sunlight on the images. We have direct or derived 3D measurements. In case of the laser scanning, from one emission I have a coordinate. In case of photogrammetry, we need to derive because we need at least two images with overlapping area to derive the 3D geometry. We have an option for professional sensors in laser scanning, but in photogrammetry we can use amateur sensors. You can use your own mobile phone for capturing the geometry of an object. But the main point is we need to select the best technology for our use cases. It doesn't mean if we have a laser scanner, then we need to use it for all the purposes. We need to select the best technology for the purposes. Okay, if you want to compare the laser scanning with traditional lens surveying methods, the laser scanning provides information from the entire surface. In case of lens surveying, we have information about individual points. We are directing points, and we have the coordinate of 1 point. So in case of laser scanning, we have random sampling, which just like a snapshot of the environment. And in case of lens surveying, we have direct sampling. The end product is point cloud on one hand and points on the other hand. We have thematic information in laser scanning because either we are measuring, we are capturing also images, so therefore we can color the points, or we have at least the intensity values of the points, while in lens surveying we have no thematic information. The laser scanning is very fast on field, very slow in office. On the other hand, lens surveying is very slow on field but very fast in office. So we can shorten the time on field with laser scanning, but in case of lens surveying, we need to think more on site. It's like engineers to decide what kind of point to measure and what not, and not design only in the office. We have, in case of laser scanning, low expertise can be also accepted, not in the processing, but in the survey, while in lens surveying, you need high expertise on demand on field. You can have various end products in case of laser scanning, like point cloud, 2D vector geometry, 3D vector geometry, solids, surfaces, surface mesh, and so on. While in lens surveying, usually we are deriving vector products. But at the end, again, we need to select the best technology for our use case. And one exciting example, it's about, I don't know whether you heard about the Roam in 1 Day project. there are certain historical sites that tourists are taking so many photos that you can reconstruct the geometry of them. That's what we did in Hungary also in case of Parliament and Heroes Care, to tourist highlights sites and spots. And since tourists are making multiple images from multiple directions, if these images are somehow geocoded, then you can create the 3D model of such objects or buildings or sites or sculptures, whatever. So literally you can go back in time by filtering all the images older than 10 years, because 10 years ago we also already geocoded some images. So all in all, I collected references here, and this is the closing video of the Capturing Reality module. Hope you enjoyed the videos. Feel free to contact us and find all the participating universities and common education programs. Thank you for your attention. Goodbye.